Oh, hi everyone. Thanks so much for showing up for your math learning once again. I return to you refreshed, recovered, and as ever, your humble math servant. Let's take a look at how we can fully factor this one. We have f of x is 3x squared minus 27. Aw man, 27 is not a square. If only that were a square, we could do something with it. Davis, what do we do?
You gotta take out the common factor.
Yeah, always common factor first. So I'm going to work horizontally here for a second. 3 multiplied by x squared minus 9. Oh my goodness, there it is. So we have f of x is, at the end of the day, equal to 3 times x plus 3 times x minus 3. So fantastic. All right, and now we are fully factored. Beautiful. Let's keep going. So complete the practice problems. All right, worksheet problems. If we have some, we can circle back. So we've already seen like this strategy of grouping and then factoring by grouping, where if we could say that this is equal to the function 3x squared plus 14x plus 8. And then we would play an x game where we want to multiply to 24, 3 times 8, and add to 14. And those numbers are 12 and 2. So you see these numbers have been used here to allow us to do factoring by grouping. And so if we were to group these two, we get 3x as our common factor, and then we have x plus 4. And of course we check it and make sure that it works. And there's our common factor 2. So that comes out of x plus 4. And then we have that common binomial factor there, which again comes out. 3x plus 2 multiplied by x plus 4. Factor by grouping. Nothing new. We've been doing that for a few years. But it shows up new. Let's keep going a little bit. New over here. All right, we've never seen this before. Here's a cubic, right? Here's a degree 3 polynomial. We've been restricted to degree 2 polynomials and manipulating those for the last couple of years. But we'll see this factor by grouping strategy is going to work here as well. So if I group the first two terms and the two last terms, one thing I notice with the coefficients, I notice that a grouping strategy is going to be effective here, not just because I'm told so by the handout. But what do you notice about the numbers 6 and 3 and 8 and 4? Yeah.
3 is half of 6, 4 is half of 8.
They have the same ratio. Yeah, they follow that same ratio. So it suggests to us that we might be effectively factoring this if we group. So what's the common factor, the greatest common factor of the first group? 6x plus 3 times 3x squared. Yeah, 3x squared is common to both. So you have 3x squared multiplied by x plus 1. And then over there, 8x plus 4. 4 is the common factor. Sorry, this is 2x plus 1. I just noticed, I'm checking my work as I go, and I noticed that I missed that. So then we have plus 4 here, and then this is 2x plus 1. As Connor noticed, we have the same ratio there and there in the coefficients as there and there, and that's why the grouping strategy is effective in this case. Okay, so now we factor that out, and we end up with 3x squared plus 4 multiplied by 2x plus 1, and we have factored a cubic. Hooray! Also, don't forget this step of pat yourself on the back and celebrate your wins. It's good to celebrate your wins in this life. Let's try this one. It's a little trickier. What's our, again, we take a look at our ratio of the coefficients. We're noticing a pattern in the variables. We have a y in one of the terms, and we don't have a y in the second one. And then there's a ratio of the coefficients. 12 is to 28 as 15 is to 35. They share the same ratio. This is the ratio of, what is that? 3 to 7. So we're expecting those numbers 3 and 7 to show up somehow here. So in the first two terms, we have a group. So we're going to factor that out as 4 is our greatest common factor, and x would multiply 3y minus 7. and then I check my work. 4x times 3y indeed gives us 12xy squared, 12xy. And 4x times 7 indeed gives us 28x. And it's negative, so that's good. And then over here, we go ahead and grab our greatest common factors here, and that would just be minus 3. So, sorry, minus 5. So minus 5 comes out, and we have 3y minus 7 again. And there you go. There's your 3y minus 7 term. So this factors into 4x minus 5 times 3y minus 7. We're all done. Okay, that's fully factored. Expand it to test it and make sure that that's true. Okay. And because this is like, it's not a trinomial, it's a 4-term polynomial. There are 4 terms here. Cubics will oftentimes have 4 terms, so they will factor in a similar way like we just saw. And let's keep going. Here we have another one that's going to, oh yeah, this one here. Solve the following by factoring. Actually, let's take a look at, there's 2 ways to do this. 2 ways. Suppose someone didn't want to muck around with factoring. What's another way we could find the values of t that make this true? Quadratic formula is the correct answer. So we can use quadratic formula or factoring here. Both are acceptable. If I have 0 is equal to 5t squared minus 14t plus 8, if I'm factoring, I take 5 times 8, which are those coefficients, or 40, and then this number minus 14. I want to factor that, so I got minus 4 and minus 10 will multiply to 40 and add to minus 14. So I'm going to decompose that middle term, 5t squared minus 10t minus 4t plus 8. We've created that situation where our grouping strategy is going to be effective. We have that common ratio between the coefficients, that pattern in the variables, so it's going to work. Our first group has a common factor 5t. And we multiply by t minus 2. And then the next one has a common factor minus 4. And that would multiply by t minus 2. So then our fully factored form 0 is equal to 5t minus 4 multiplied by t minus 2. And then we want to go ahead and find our values of t that make this true. How do we do that? Eva?
Set it equal to 0 and get t by itself.
Sure. Yeah, we have 2 options, 2 things that could either one be 0, right? In a universe where briefcases of cash exist and there's some number of dollars in the briefcase, if you tell me you have $0, then one of 2 things is either true. You have 0 briefcases, or you have $0 in each of your briefcases. Those are the only ways that you can have $0 in this universe. So in this case, here's our number of briefcases. 5t minus 4 could equal 0, which solves to t equals 4/5. So there's one of our values. And then if t minus 2 is 0, you just set it equal to 0 and add 2 to both sides, and you get t is equal to 2. So there's our 2 options. All right? But we also know we can use quadratic formula as well. So let's take a look at what that looks like. When you have 0 equals, you must have 0 equals and then some variable here, t squared, 5t squared minus 14t plus 8. One thing we might check before we use quadratic formula and go to all of that trouble, what can we check to see if solutions do exist at all? How could you find out? Kunal?
If the thing under the square root, how do you do that part?
The thing under the square root has a special name. Does anyone know the special name for the thing under the square root?
Discriminant?
Yeah, the discriminant, because it discriminates your 3 different situations. You're in, and also a visualization can tell you what situation you're
Excuse
in.
the interruption.
Never.
In the student parking lot, there is a brown Hyundai Tucson with license plate BLTJ384.
Oh, BLT.
If
That's
this
a
is your
cool
vehicle,
license
can
plate.
you please
It's
move
named
it
after a sandwich.
immediately? Again, brown Hyundai Tucson with license plate BLTJ384. Thank you.
Bacon, lettuce, tomato, and jam. Maybe it's like a new taste sensation. If anyone makes their first million with a BLTJ restaurant, it started here, and everyone will remember it. Okay, so we can visualize this thing. Here's my x-axis, here's my y-axis, and I like to think of myself as the king of the quick sketch. Here is our y-intercept. So it's crossing up there at 8. So that's the information that this coefficient, so make a little cheat sheet for you. A is equal to 5, B is equal to minus 14, and C is equal to 8. People knew that about C, right? That's not new information? You knew that just gives you the y-intercept? Great. What does the A value tell you? The sort of the vertical stretch, yeah, and direction of opening, right? So this one is opening upwards, and it's very curvy. It turns around very fast. What does the B value tell you? It was quiet before, but it got really quiet then. No one knows, except for me. You know?
Left-right shift? No.
It is related to that. Kunal?
Compression?
No. The B value has a really cool property, okay? The B value tells you its behavior as it's crossing the y-axis. Notice, if we didn't have this part, the 5t squared, it would not be quadratic anymore. It would be what type of function? Just minus 14t plus 8? It's linear. If you graph minus 14t plus 8, you get a line that's diving down as it crosses the y-axis, right? That is exactly what the function is doing right at the y-axis, but it immediately starts turning away and turning away on either side of the y-axis. That's the quadratic part is curling it up from that line. But the parabola absolutely does have a slope or a rate of change as it crosses the y-axis, and it's minus 14. That's what we would call its instantaneous rate of change as it's crossing the y-axis. Very live idea for you as you go into calculus. Okay, where you're going to be working on that stuff. So this tells us that this parabola comes down very quickly, turns around and goes like that. So we're suspecting that it might have two positive roots. And we could check the discriminant to see if it does. So I quickly check b squared is 14 squared is, what is that, 196. 196 minus 4 times a times c. 4 times a is 20. 20 times 8 is 160. 160 is less than 196. So yes, we have roots. We have two of them because the discriminant is positive. So check that first and it saves you some time. Okay? So now we go ahead and we say, okay, so t equals, oh gosh, I forgot the quadratic formula. So what do I have to do if I forget the quadratic formula? If you said check your tattoo, you're right if you have the tattoo, but that'd be cool. I just got a quadratic formula. Yeah, so you have to sing the song. Okay, you have to sing the song. So you say negative b plus or minus the square root of b squared minus 4ac over 2a. Then you never forget. You get a catchy song in your head. Check YouTube if you don't believe me. It's there. Okay, always copy out the formula. This is important for communication. It shows your reader where your ideas are coming from, and it helps you locate any errors if you do make them. It will help you avoid errors by copying out the formula. So there's so many good reasons to do it. In this case, t equals negative 14, so that's positive 14 plus or minus 14 squared is 196 minus 4 times a times c, that was 160. Okay, you can substitute into brackets here, or if you want to accelerate things a little bit, do it that way. All over 2a, so that's 10. It's not bad. I think this is an acceptable number of steps skipped, but just make sure that you can check your own work, right, and verify it. I can verify that that's true, so I'm comfortable. So this is 14 plus or minus the square root of 36 over 10. So we are 14 plus or minus 6. So 14 plus 6 gives us 20 over 10. So t equals 2. Or 14 minus 6 is 8 over 10, which is 4/5. We already knew that. And for those of you who are seeing the connection between factoring and quadratic formula, you can actually use quadratic formula to factor. You just take these roots and throw them inside in here and make sure that your a value doesn't change. And then you can use quadratic formula to actually create factored form if you prefer doing it that way. That's acceptable. So practice away, get some practice. I haven't posted any Delta Math yet, but we'll get going on that next week. And you have the handouts. Any questions, bring me over to your table groups. I remain your non-malfunctioning math servant, Mr. Jennings.